Intellihot has a patented low-loss header design. A low-loss header is a concept that's applied primarily in the hydronics world. It is a method upon which you can use hydraulic separation to mitigate pressure drop. And that's a lot of words, but essentially what it means is that in a low-loss header, you do not force all of your flow rate through your restriction. In our system, what that means is primarily what's going to happen, and as water comes in for the cold water line at the bottom of the unit, by the way, this is an IQ 751 we've got on the screen here. Water is coming in through your cold water supply at the bottom and being forced by the pump through the heat exchangers. As flow goes through the heat exchangers, it does drop a little bit of pressure, and then it comes out and gets delivered to the fixtures. Now, what happens when flow starts to increase is that a small amount of flow starts to go through my bypass line. This is why the bypass line exists inside our units. At a certain point, the pump pushing flow rate through the heat exchangers is no longer the path of least resistance. So water starts to flow up through the bypass. This is why we have manifold inlet and manifold outlet temperature sensors. The temperature sensors are going to correct the outlet temperature for the small amount of flow rate that's bypassing through the bypass line. So your heat exchangers, say you've got your unit set to 140 degrees. The minute I start bypassing water through the bypass line, my heat exchangers start to fire a little bit above 140 degrees. Now I'm delivering water from my heat exchangers at 150, 160. Okay, and that's mixing with the water at the outlet, which is providing the temperature that's desired to the fixtures. Okay, now, why are we designing the unit this way? Well, when I have a 50 GPM event occur across my floor mount unit, rather than trying to force 50 GPM through my 3 heat exchangers, which I won't be able to do, I allow some of that flow to go through my bypass. This is a core tenet of our modular design because it allows multiple heat exchangers to work together in order to meet the capacity of the system without dropping all of the pressure that you would if you had to force that flow through your heat exchangers. Okay, that's important to remember with this design, that the pump is always running. So in the event that there is no external demand through the system, the flow will rotate back through and create a recirculation loop inside of the system. Okay, so flow rate moves this way. The pump is not meant to provide recirculation to the building loop. The pump is a piece of this low loss header design. So it's meant to do those two things. It's meant to force flow rate through my heat exchangers and to recirculate. You can imagine a scenario where if the pump was not present inside of this system, all of your flow rate would just go through your bypass because you have way less restriction through your open bypass line than you do through your heat exchanger. So the pump is actually an integral part of this. This is why on the IN199, we have a pump. Pump is forcing the flow rate through the heat exchanger. Okay, and the bypass line is normally open on our units. That's normal operation. The bypass line is going to close if my pump is in fault. If I can't get power to my pump or the pump isn't pushing, I close the bypass line and then I force all of my flow back through my heat exchangers. Okay. Contractors are going to be very amenable to this because contractors understand that when designing a system or implementing a system in a large commercial building, pressure drop is a big concern. Okay, and many of the plumbing contractors you're going to talk to are going to be familiar with what a low loss header is because many of them have worked on hydronic systems.